Hi, hello, I'm Kiran Kumar from Nature of Physics. Today's topic is Law of Conservation of Linear Momentum. According to the law of conservation of linear momentum, it states that the total momentum of an isolated system is remains constant if there is no external force acting on that. Okay, student? So that whenever external force is 0 on the system, total momentum of the system is remains constant according to the law of conservation of linear momentum. So derivation I am going to explain from the Newton second law. From Newton second law, dp by dt is equal to F external force. The rate of change of momentum of the body is directly proportional to the external force. Here the condition is if F external force is equal to 0 student, then dp divided by dt which is equal to 0. Now differentiation of constant is equal to 0 student. So that p which is equal to constant, p is equal to what student? Constant. Here we can write there, here we can write differentiation of constant d by dt of constant is equal to 0. Okay student, then p is equal constant, nothing but p is equal, the formula is mv student. So that is momentum. So that I can write next mv is equal to constant student. So first one p is equal to constant, second one is mv is equal to constant because of p is equal to mv student. Here the velocities depend on the mass student like this. Okay, so that velocity is inversely proportional to the mass according to the second equation student. Here mass is minimum, then velocity is maximum student. Okay, and also if mass is maximum, velocity is minimum. Okay, and second derivation also is there student. So here average momentum is considering, that is delta p divided by delta t which is equal to F external force student. If F external force is equal to 0, then tell me student, delta p divided by delta t is equal to 0 student. Now delta p which is equal to 0 I got student, but delta p which is means cross multiplication I did, delta p is equal 0, p is equal constant. Okay, but here average value considering, that's why delta p which is equal to pf minus pi student, the value is replacing there. So that 0 is equal to pf minus pi student. So that I can write pi which is equal to pf. Initial momentum is equal to final momentum when the external force is equal to 0 student. Here also from this equation I can write m1 v1 is equal to m2 v2 student. m1 v1 is the initial momentum and m2 v2 is the final momentum. Okay, this is the law of conservation of linear momentum concept student, and two examples are there. So first one is gun and bullet concept, that is here clear diagram is given student. Initially gun at rest student, that's why initial momentum is equal to 0 student, and final momentum I am going to write here m1 v1 plus capital M into, that is m2 v2. Here I am considering, notice that small m is the mass of the bullet and capital M is the mass of the gun student. So bullet velocity after firing is v1 velocity and gun is in opposite direction with a velocity is v2 student. Okay, So according to the law of conservation of linear momentum, I can write initial momentum, law of conservation of linear momentum, that give initial momentum is equal to what, student? Final momentum. What is the initial momentum? Initially gun at rest, that's why initial momentum is equal 0. And what about final momentum, student? Small m is the mass of the bullet which is moving with a velocity v1, and capital M is the mass of the gun which is in opposite direction, okay student, with a velocity v2. So that I can write there capital M minus v2 which is equal to m v1, student. There minus represent is opposite direction, student. What is the direction? Opposite direction. Minus represent opposite direction. One thing we have to notice here, the velocity of gun is inversely proportional to the mass of the gun, and velocity of the bullet is inversely proportional to the mass of the bullet. See student, here bullet mass is minimum, that's why velocity is maximum, student. Here gun mass is maximum, so that gun velocity is minimum, backward direction, student. Okay. So action and reaction, like we can consider here Newton's third law obey the law of conservation of linear momentum, that is law of conservation of linear momentum only obey the Newton's third law, student. And continuation, next step is here bomb initially at rest, student. Initially rest nothing but initial momentum is equal to 0. So finally it will break into two fragments, student, m1 and v1, student. So I will write this is m1 and that is, sorry, left side is m2 and right side is m1, student. m1 moving with a velocity v1 and m2 is moving with a velocity v2, student. Now I am going to write the law of conservation of linear momentum. Initial momentum is equal to final momentum, student. So that value is replacing initial momentum is equal to 0 is equal to final momentum is m2 v2 plus m1 v1, student. And same method m2 v2 minus which is equal to m1 v1, student. Okay, m2 v2 from RHS side to LHS side. Again here minus represent what is that, student? Opposite direction, okay na. So that the equation now I can write m1 v1 is equal how much, student? m2 v2. Okay student, this is the law of conservation of linear momentum. Okay, so third example is there, that is a rocket is, student. So completely we need one video, student. I will post that. Please do like and subscribe my channel.